Greetings, AP Chemistry students. I want to go over a couple of things with you real quick. The first has to do with the Henderson Hasselbalch equation here. I want to point out that you can only use the Henderson Hasselbalch equation with a buffer. If I had asked you to calculate the pH of a zero point 0.3 molar acetic acid solution, well, if you tried putting in zero point 0.3 molar for your acetic acid, well, you don't have a base concentration. So you put in a zero and then you try to take the log of zero. Well, you're going to run into some serious problems because you can't take the log of zero because there is no power you can raise 10 to get zero. Also, if you only had the conjugate base present and you tried plugging in, then you would have no acid and you'd be dividing by zero. You can only use the Henderson Hasselbalch equation for a buffer solution. And in fact, you don't even have to use the Henderson Hasselbalch equation then because you can always just use an ice chart. Now, the other thing I want us to talk about is, let's say we're doing a titration of HY with sodium hydroxide to make water and obviously the NaY. If we did this as a net ionic equation, we would leave out the sodiums and it would be OH minuses and Y minuses. Now, the equivalence point will happen here. And since this is a weak acid, that's going to be an equivalence point that's higher than a pH of 7. Halfway to the equivalence point, whatever this pH is equals the value of the pKa. That's halfway to the equivalence point. Just find that point right there. So we go up halfway and find it. Now, prior to the halfway to the equivalence point, if we were asked what the major species are in solution, well, at the very starting point, it's HY. In this region, right through here, the major species are HY and also Na pluses because, let me make this look a little better, because you're adding sodium hydroxide, and anywhere past the starting point, sodium ions are going to be quite prevalent in solution. You're also going to have H pluses present in solution because if your pH is less than 7, if pH is less than 7, you have H pluses in solution. If pH is greater than 7, you have hydroxides in solution. Now, after the halfway to the equivalence point, more prominent than HY becomes the Y minus ion. But you also still have the sodiums, and until you cross that threshold of a pH of 7, you also have H pluses. Once you get up here in this region, you have Y minuses, you have Na pluses, and you have hydroxides. You do not have H pluses in any significant amount, and you definitely don't have a lot of the HY either. So I hope that just clarifies a few minor points for you.